Welcome to clickmyprojects.com. Now we are going to see the paper related to adaptive workload prediction of grid performance in confidence windows. This paper comes under the domain of parallel and distributed systems. First of all, we are going to see what is parallel and distributed systems. Distributed systems is concerned to network of computers, that is network of nodes. Physically it is being connected in some geographical area for handling multitasking, workload predictions and all. Not only for these things, it is these combinations, I mean the distributed system framework is being handled for multiple purposes, that is in order to estimate the workload and for task sharing, and then for having their reliability. Okay, in this paper we are in need to know some other domains, that is grid computing. Okay, so what is grid computing means? It is nothing but sharing of resources. The resources may be of any form. It may be a file, or it may be a printer, or it may be a node processing, that is what is a CPU, right? So all these things are shareable resources, that is. Okay, grid computing emerges as a distributed infrastructure for large-scale data pre-processing and then scientific computing. So grid means different people are different backgrounds, and so different nodes are different backgrounds. That's it. In technical, we are need to see. Grid is mined from the edge of the internet. So it is obtained as some real-time scenarios are also available. There's nothing but various at various home projects, and then ACTE, folding, Einstein at home. So these are the real-time grid environments that are available. Accelerated grid performance is another vital issue that we are going to address in this paper. Okay, so what is this accelerated grid performance? Speedy grid performance issue. That's the thing. Okay, so of course, while collecting all the workloads, we are in need to have the execution faster. In the sense, we are in need to predict something priorly in order to avoid all these circumstances. So that is a major challenge that is addressed in the paper. So accelerating grid performance is directly associated with executing number of processes. However, predicting the aggregated workload is a very challenging task. It is because some tasks will be occurring at long session, or some may be in smaller sessions. That is a major thing, which is called as load fluctuations. So it is harder to predict due to the load fluctuations. Okay, then what kind of issues or what kind of things they are used to in existing system means it is nothing but point value prediction methods. These methods are applied. Actually, what is the demerits regarding this paper means it will be working well in order to predict the CPU load in centralized computing systems. Then what is the main issue means it didn't work well with large scale producing grids. In the sense, these Einstein at home, these real grid environments were not sufficiently working with respect to that particular method. So we are in need to have some other method, and moreover another thing what they are saying is workload measurement errors are also occurred. In the sense, they will be having some wrong prediction of workloads in the peak hours or non-peak hours. So that is the noise. It is called as noise. So these are the issues that is being occurring in terms of accelerated grid. Now we are going to see the flow of the particular concept. So initially, what method they are going to propose is adaptive method. So this method is going to predict the workload for parallel execution on grid resource sites. So what are the things that is being applied means Kalman's filter and Savitsky-Golay filterings, that is smoothing techniques, are applied in order to filter out the prospective errors. Predictive workload is also containing those errors, right? So that was a major drawback that is being stated in the existing system. So we are going to avoid all those things by applying these smoothing techniques. Hence, those filters that is being applied are applied in the confidence window generation. This is in the sense it is going to predict the future workloads. That's the thing. Okay, and this is followed by mean square analysis also. So this is nothing but to lessen the errors. That is mean square error analysis. So this scheme is used is going to use some historical interval. So that is going to dynamically trap and validate the past workload series. These things, these subjective things, this vital thing is said to be adaptive prediction scheme. So we are in need to subject some interval, workload interval, to correlate the future workloads. So look ahead span and training period are going to are being used for validating the workload, that is future workloads, whether it is in an apt manner or not. That is the main aspect. That is the main concept of this particular approach. So this procedure contains several steps. That is, we are in need to organize the grid nodes, then affording the workloads, then examining the workload characteristics, which is modeled here, that is here, and then we are in need to have the measurements such as workload confidence window generation and smoothing and mean square analysis, and finally adaptive prediction scheme. So this is the main role of this particular, major steps carried out in this paper. So that is the main concept. Now we are going to run the project. For that you are in need to have the NetBeans, and you are in need to open the WAM server. Here is the WAM server, and then you are in need to deploy all the things. Then, and that is you will be having one file that must be placed on E colon. That file is nothing but it is containing adaptive. The name of the folder is adaptive. That's the thing. Now you are in need to open this upload.java, and then before that you are in need to add the libraries. Of course there is one package given, so out of that you are in need to give this add jar folder, and you can just select the jar files which is being given. Of course all the things are already selected, so no need to select it again. Now upload.java, start running this form. Now I'm going to give the input for the particular server for executing. Just give select some file. You need to select this XLS file. Okay, no need to select other files. Okay, so I'm giving these 5 files for execution. So I'm going to submit as job, then extract the features. Those jobs is being extra. These are the contents that is present in each and every file. So of course the contents will be varying, and now we're going to allot it for the nodes. Of course there are already 42 processes it seems. Now 42 plus 5 41 process. Okay, so this 5 is being added, total process is 46. Now we are going to initialize the thing. Of course it will be taking some time to execute. It will be taking some time to execute, as it is being actually what it is doing is each and every job, 46 job is sent to 46 nodes. There is some amount of resources, and it is getting executed. That's the thing. Then so these are the nodes for which the execution is being carried out. Okay, and then so this is the processing time of grid. Then processing time, we are need to analyze the cost for each and every node, and CPU utility is also analyzed. After that we are need to predict the workload indices. Totally 46 jobs, right? So T1 to T46, T45 starts from T0. Okay, workload indices are being predicted using Berg's algorithm. So this is a Berg's value. Okay, and then auto regression parameters are evaluated. This is nothing but Kalman's filter. Leveraging is nothing but smoothing, that is error values are being estimated. So this is the this is the original value, and this is the leverage Kalman's value. That's the thing. And then error rate for each and every 46 jobs is being estimated. And then Savitsky-Golay. So Savitsky, according to that, for each 46 job, what is the Savitsky smoothing value? Of course it was a very large value, right? See, e power 204 of. So this value is being synchronized into a small value. So this is the value. And after that I'm going to give the confidence level limit. So 46 already we are having, plus 10 time limits and 10 seconds. Okay, then we are need to predict the A of I value. So this is the A of I value for the next one. Next is confidence interval. So this is the confidence threshold, that is maximum threshold and the minimum threshold. Maximum the job it will be this much, and minimum value will be this much. Now we are going to have the training and testing process. So this is a training process. Okay, so this is a for each now 46 we are having. After 46 to next to 10 we are having the things, right? So this is 0 1 2 3 4 5 6 7 8 9 10, and ST is something standard deviation value. Now we are going to test the thing. So I am going to give the time limit as 10 to 15 confidence threshold. Okay, so value the mean value of the confidence threshold is this much, and then MSE value, mean square error. The graphs are being drawn. Look ahead span and the error rate. That's it. So in this way we are going to predict the future workload. So after 46 46 to 56, this much amount of workload will be present, and 10 to 15 means the mean value will be this much. So the amount of workload which will be estimated is this much. That's the thing. Okay, thank you, thanks for listening.